want us to look at this question together. A diver is attempting to dive from a springboard that is 6 meters above the water. He leaves the springboard with an upward velocity of 7 meters per second. Now, taking the value of g as 10, we have to find the speed at which the diver enters the water and the time for which he is in air. So I want you to look at this question very well. It's still under motion so that we can try to find a solution to it. I'm going to take this page up so that I can have enough space to solve this question. Okay, so let me see. The diver is on a springboard and the level of the springboard is 6 meters above the ground. See, this is the diver on the springboard, and the level of the springboard is about 6 meters above the water surface. 6 meters. This is the water. Now, this diver is going to lift from the springboard with a speed of 7 meters per second. That's the initial speed of the diver. I'll call that the initial speed U. Now, what we do in calculating or solving problems like this is that we assume a direction for the motion or the velocity of the body. So if I take the upward direction of the velocity as positive, it means that any direction that is downwards will be taken as negative. Recall that the acceleration due to gravity always acts downwards. So my g will be negative because I've taken the upward direction as positive. The initial velocity is in the upward direction. Okay, so that's the direction and the magnitude of initial velocity. So my acceleration is going to be minus 10 meters per second squared. Okay, so we want to find the speed at which this diver enters this water below. Now, at the point when the diver enters the water, we can decide that at this level, the diver's displacement is 0 because this is the same level as it was before he took off from the springboard. So when he's back to the same plane from which he projected himself, when he's back to the same level he was earlier, then his displacement is 0. Now, it means that the displacement from this level to the water, we're going to take it as negative because it's below the 0 line. So my displacement here, I'll take it as minus 6. So my u is acting in the upward direction, and that is 7 meters per second. The value of g, since I've taken this direction as upward, g acts downwards. So that's why it has a negative. The displacement when the diver enters the water, we'll take that as minus 6 meters because it's below the level from which he projected himself. Now, what equation do you think we should use to solve this problem, to calculate the speed of the diver? If I decide to use the second equation, because I have my u, I have my s, I have g, then I need to find v, which is unknown. So since I want to find the final speed, the speed at which the diver enters the water, then I can use equation 3. Equation 3, I recall that is v squared equals u squared plus 2as. Now, the v squared is what I'm looking for. That is the final speed v. My u is 7. That's 7 squared plus 2 times my a is minus g. A, the acceleration is minus g, which is minus 10 times my displacement s is also negative minus 6. So that will give me v squared equals 49 minus by minus is plus. 2 times 10, 20 times 6, that's 120. So by the time I sum both of them, I have v squared equals 169. So the v, I take square root of both sides. Square root of 169 will give me 13 meters per second. So the diver enters the water with a speed of 13, having taken off from the springboard with a speed of 7 meters per second. Now the next question says the time. Calculate the time for which he is in air. We can use, since I've got my final speed, I can use the first equation of motion, v equals u plus at. Now v is 13, u remains 7, my this a is minus 10 times t. That gives me 13 minus 7 equals minus 10t. Now since my velocity v is acting in a downward direction, there's something I need to note there. It's supposed to be a negative value. We are supposed to accept, since we have taken positive direction or upward direction as positive, any direction downwards will be taken as negative. Because I took g as negative, my final velocity is acting this way, so it's going to be given a negative sign. Because of that, this ought to be minus v. I have to take that as minus v, so this is minus 13. Upward velocity is taken as positive, then downward velocity will be taken as negative. So that gives you minus 13 minus that is minus 20 equals minus 10t. So dividing both sides by minus 10, I will have negative cancel negative. My time t is 20 over 10. That gives me 2 seconds. So it's going to take 2 seconds for the diver to strike or to land on the water surface.